This video is briefly about the outlines of biochemistry and then to project or highlight the relevance of biochemistry as a part of curriculum for the medical graduates. Fundamentally, the biochemistry, as assumed by many, it is not full of chemistry and it is more of bio and less of chemistry. To put it simpler, I say it is an attempt to understand how the life is being maintained and sustained in the form of biochemical reactions occurring in the body. And when something goes wrong in this sequence of biochemical reactions, how it can lead to a disease. So it explains the root cause of many of the diseases when there is a disturbance in this biological activity which is occurring in the form of biochemical reactions. At the same time, it gives us the sound knowledge of how the health is being maintained. The word health is a very broad term here to say, but I try to explain in relevance to maintenance of the health how this biochemistry is throwing light to understand. So usually, like any other living organism, we also need food for our growth and for the sustaining of life. And food that we take, essentially, the first thing that is taken care of in the body soon after the food that you take, after the digestion process is over, body tries to generate energy using this fuel and it tries to meet all the energy requirements of the body. And this energy requirement in the body is a 24 into 7 demand. Not even a second, the body, the process of life, the biological activity is not able to sustain without the supply of energy, even for a while. So there is a continuous need for the supply of energy. The first thing the body does after the process of digestion and absorption of the nutrients in the body is pick up these fuels. So usually these are the carbohydrates and lipids and burn them. And in the language of chemistry we say they undergo oxidation and they derive energy. Then after the production of energy, just like we spend the money for our needs and over and beyond the money that you have after meeting your needs, routine expenses, just like we put it in the bank. Similarly, after producing enough of energy, which is continuously meeting the energy demands on the body, day in and day out, the excess of the fuel, which is derived from the food that you take, they are preserved in the body, they are stored in the body, and both the carbohydrates as well as the fats, and scientifically we call it as lipids. So both these carbohydrates and the lipids, they are stored in the body, and carbohydrates are particularly stored in the form of what we call glycogen, and a large extent it is stored in the liver, and also to an extent it is stored in the muscle. And fats are stored in the form of a fat what we call triacylglycerol, which is the fat that you see below the skin is nothing but the fat which is called triglycerides. So both these triglycerides that you see and the glycogen that you have in the liver, these both are the energy reserves in the body when you are falling deficient to the nutrients or when you are on fasting, when you are on starving. So in those times, to meet the energy requirements, these stored energy reserves of the carbohydrates, that is glycogen, and also for the fats, that is your triglyceride, they are broken down and they are made to undergo. They are burned for the generation of the calories. And usually, soon after for the digestion and absorption of food, the routine process usually is to generate energy. Excess goes for the storage, and even beyond after the storage, whatever that is derived from the digested nutrients, the digestion process is nothing but making the complex molecules into the simplest molecules. And these simplest molecules, once after absorption, when they are in the blood, they are picked up, these elementary molecules, and they go into the formation of many other important biologically active, physiologically active molecules which are synthesized or produced within the body. So these three events happen once you take the food. One is generation of energy, second is storage of this energy substrate, and thereafter, over and above that, the molecules which are derived from the food nutrients, they are utilized for the production of other important physiologically active compounds. So this production of energy, we call it as a catabolism, and this production of other important biomolecules, we call it as anabolism. And there is a shift in the activity between your anabolism and catabolism depending upon the energy state. When in need of energy, this catabolism goes on, and when enough of energy is produced, this anabolism, the synthesis of new molecules goes on, and the balance between transition state, or the balance between this anabolism and catabolism, is what we call metabolism. So the whole of biochemistry is about this metabolism. So basically, it throws light on how the life is being maintained, and anything that goes out of order in the sequence that I have described in the process of which is occurring in the form of biochemical reactions, either in this anabolic or catabolic sequence of reactions, that could lead to disease. So that is also going to, the knowledge of the biochemistry also helps you to understand how a disease can be caused at the molecular level. At the same time, the knowledge of this also, it helps in diagnosing and also to assess the severity of the disease, what we call prognosis. And also in research methodology, it also lays the foundation for the designing of the newer molecules which can be used as therapeutic agents. That is, what I mean is as drugs to treat different diseases. So the basis of biochemistry, it helps in understanding how the life is maintained, and it also helps in understanding how a disease can be caused, and it also helps in diagnosing and assessing the severity of the disease, and it also helps in arriving to choice of drugs and designing of the drugs to treat different diseases. Thank you.